Gene discovery. They're out there, waiting to be found. Let's open our eyes, crawl out of our caves, and go.
Okay, so sorry about the bad sound quality there, but okay, so basically on the agenda today, we're going to talk about new discoveries coming from Sophos. But first of all, to understand what we need to discover, we need to have a look at today's current threat landscape. So I'm going to talk a little bit about what we at Sophos see, the current trends with malware, and also go into more depth about these types of malwares that we see. So this is just a general overview. We've probably seen similar pictures from other vendors a million times by now, but just to give you an idea on what we're doing. So of course there's many different types of malware that we detect all the time. So 150,000 suspicious URLs per day, which is quite a lot. 300,000 new samples of malware every day. 5 million spam emails per day, and 600 million live lookups per day. So we have a lot. But there's one particular piece of malware that has really gotten a lot of attention, and I thought that we should have a closer look at that one. And it's called ransomware, or the general term for this piece of malware is called ransomware. Is anyone here familiar with ransomware? Yeah, most of you? Great. Okay, so just a brief history of ransomware. So the first piece of ransomware was discovered in 1989, a long time back. It was called the AIDS malware. And actually, like one of the statements there, like, there is no cure for AIDS. So, basically, what would happen if you got infected by the AIDS ransomware? Let's see, a lot of people dropping in here, so. Great. Let's give it a few more seconds. Great. Okay, welcome everyone. So, we're talking about what we're seeing with Sophos Labs, the current threat landscape or current trends within malwares. So one piece of malware that we're seeing quite much in media and so on is ransomware. So I thought we'll have a closer look at this. So ransomware, as I mentioned here, this is the first piece of ransomware that was detected in 1989. Basically what it did was, if you got your computer infected by this AIDS malware, it would say that one of your programs installed on your computer has expired and you would need to pay $189 to be able to continue using that program. Very easy. The law enforcement actually caught the makers of the AIDS malware, and it completely disappeared for bunch of years. Then in 2005 and 2006 we could see ransomware again started to gain momentum, and it's in 2013 that we really saw a particular nasty piece of ransomware that we're going to talk more about, Cryptolocker. But if we look at the first pieces of ransomware, this was one example. You basically got an email, you clicked on the link in the email, and you got this very nice screen on your computer saying that you would need to pay $200 because you've been on different child pornography sites and so on, so you need to pay this ransom. This was quite harmless, to be honest, on the computer. If you disinfected this from your computer, nothing happened. So all your files will be restored, and you can continue working like before. But these were designed to basically trick you into paying the amount of money that they wanted. Fake antivirus is another example. Basically, presented a scan of your computer saying that you have approximately 200 infected files. For you to be able to disinfect these files, you would need to purchase a premium license for an amount of money. Once again, those types of malware were by themselves not harming the computer. They were really annoying. A lot of people actually bought this and they paid the money to the bad guys. But if you had a proper antivirus solution installed on your computer, you would be able to disinfect this malware. However, in 2013, we saw a new generation of this type of ransomware called Cryptolocker. Is anyone familiar with Cryptolocker here? So, some of you, feel bad for you. Hopefully you haven't gotten infected, but anyways, so Cryptolocker, just brief history on Cryptolocker. So it was developed in 2013. In 2014, law enforcement actually took down the makers of Cryptolocker. However, what Cryptolocker did was basically give out the source code so that anyone could keep developing this malware. One really interesting fact is how much money they actually made on this. So, according to the US Department of Justice, Cryptolocker earned approximately 27 million US dollars for the owners in just 2 months. So, I understand why they keep making these types of malware. So, many different versions. This was one of the first ones. Basically, when you get infected, you get this screen presented for you. You have to pay an amount of money to be able to decrypt your files that have been encrypted. Then, once the shell code was out, the source code was out, we started to see another couple of variants of the Cryptolocker, and this is the Cryptolocker version 3. So, and it's quite interesting. Basically, you have some time left. It's a counter, 4 days, 23 hours and 59 minutes to pay the $300 US. If you don't pay the money within that time, they are actually nice enough to just double the amount of money and give you some more time so you will be able to get your files back. But as I mentioned, we see a bunch of different versions of ransomware nowadays. So Cryptolocker is not that existing anymore. It's more other versions like Firewall is probably the most famous one. Torrent Locker, Cryptolock, Cryptvault, and so on and so on. So these are typically the file types that they're trying to encrypt. Basically anything that has value for you. So everything from your documents that you have on your computer, pictures, PDFs, Excel sheets, and so on. The encryption algorithm that they're using is usually 2048-bit encryption. So Sophos doesn't have a magic tool to decrypt these files, sorry. If you've got infected by this malware and it has encrypted your files, there's no way to restore those files, sorry to say. If we look at the Cryptolocker and how many infections we have seen, so this graph shows you a little bit on the different countries of endpoints infected by the Cryptolocker. And you can see that US is approximately 7%, and then if we combine all the countries within Europe, we end up at approximately 35% in Europe. But you see there are others, 53%. So the origin of Cryptolocker has actually been tracked by Sophos Labs very carefully. And we saw that it began in Australia. So they started to send out mails using the Australian Post Office to users. They clicked on a link, they got the malware, and they got infected. Then it moved from Australia to Asia, Southern Europe, Northern Europe, and then to US. And that's the pattern that we've seen with these types of crypto malware. So I mentioned the usual, this is the most common way to get infected by Cryptolocker. What would happen is that you would get an email, usually from your post office or from DHL or something similar, with an attachment. A zip file that's password protected so it can pass through all spam filters. And you get a password for that zip file, so the user can just open it, unzip the files, and in there is an .exe file disguised as a PDF file. This is like the oldest trick in the book, basically. But still we see a lot of users actually falling for this. When they have double-clicked on what they think is a PDF file, which actually is an .exe file, the file will simply disappear, and a Zbot malware will infect your computer. The Zbot malware will then start to download the crypto malware, and the Cryptolocker gets installed. After that, when the installation has been completed, it will always contact headquarters. This is always the first step that these types of malware does. So basically it will contact botnet servers, it will create a handshake and exchange the keys. So one key will be stored on the botnet server, on the bad guy servers, and one key on your computer. Then the actual encryption part takes place. So it starts to encrypt all these files, like Excel files, like pictures, Word documents, and so on. Anything that basically has any value for the end users. And then you get the extortion. So just to show you, I didn't want to infect this computer, so I just had a video to show you exactly what it looks like. So we have a user here. He's working on his files like normal. Everything is working as it should. He can open them. But then he takes the zip file. He has a very suspicious file, .pdf, as you can see. If we look at the file extension, you can see that it's .pdf.exe, as I mentioned, the oldest trick in the book. He double-clicks on it, and it disappears, and these two new services has started. And you can the process to encrypt the files is really quick. It doesn't take more than 10 seconds before this is displayed for the users. So you have two different choices to pay the bad guys to get your files back. One is to use bitcoins, the other one is to use MoneyPack. MoneyPack is only available in the US. They also changes the background, and now when you try to open your files, they will just not be able to open. So, in my opinion, I mean, this is just as evil as it gets, basically, when it comes to malware. And as I mentioned, there is no magic cure. If you've come to this stage and your files are encrypted, there's really nothing that Sophos can help you with, or any other vendor for that matter. You would need a really big supercomputer to be able to decrypt the files, and it will take you 30,000 years or something like that. So, yeah. So, what we at Sophos are doing is, of course, working a lot with this. We're analyzing this. As I mentioned, we've followed the Cryptolocker throughout exactly the origin and had a look at closely to see, okay, different behaviors, how can we detect this, and so on. So what we're doing is we already have what we call the next generation threat, next generation protection. And I think this is probably a marketing thing, but different, well-known explorers like Galileo, Copernicus, and Kepler. One particular project that we're working on is the project Galileo. And basically, in your environment, you have different security components. You have an antivirus on all of your computers, you have a firewall that's protecting your gateway, and so on. With the Galileo project, what we're doing is combining these different modules so that they can actually talk to each other to give you a better security overview in your environment. So if we take our endpoint protection as an example, our endpoint protection contains of many different filters that protects your computer. So you have on-access scanning, which is this was what we started doing with signatures, 1985 when Sophos was founded. Basically how signatures work is that if we have a malware, we take a fingerprint of that malware and put it in a database. Then when a new file is started on a computer, we simply compare that file, we take the fingerprint and compare it to a database and see, okay, is this malware or not? We have web protection in our endpoint protection. So basically what we're doing, since most of malware is coming through the web, like 80 to 90% of all malware infections is coming through the web, it's really important that we can filter all traffic coming from the web. We're using reputational filtering, so we can actually, in the beginning there you saw that Sophos Labs detects approximately 100,000 URLs every day that are spreading malicious code. Those 100,000 URLs are added to our reputational filtering list. So if a user would try to go to one of these URLs, you would not be able to. We will simply block you from accessing that web page that's currently trying to infect computers. Live protection is a way to basically have a direct connection from your endpoint to Sophos Labs. So if we detect a piece of malware in China, we can then directly protect all of our users across the world from that particular piece of malware. So real-time protection with live protection. HIPs are behavior analysis. So instead of looking at the signatures, looking how a malware looks like, we're looking at what is the process actually doing. This is today one of the most important features to have in an antivirus solution. For us, this covers approximately 70 to 80% of our detection rate is built on the behavior analysis. And we also added a filter called Malicious Traffic detection, which looks at what are my programs on my computer, what are they communicating to. So for example, if you get a malware that's trying to contact its botnet server, we can see that this is something strange, and we can block that application and remove that particular application that's trying to do this malicious traffic. So what's also unique with Sophos is that we have these individual filters, but they can also communicate to each other to give you a better holistic overview of the system. So let's say, for example, the behavior analysis detects that, okay, this particular file is doing something strange, but it's not 100%. We can't say for sure that this is malware. It can then just flag this particular process that's doing this suspicious behaviors and tell the rest of the engines to keep a lookout for this process because we've seen something strange from this. And then if malicious traffic detection, for example, detects that, okay, it's also trying to contact the botnet server, then we can for sure say that this is malware. So if we take the Cryptolocker again, so Cryptolocker uses polymorphic signatures. Basically, if my computer and this computer is infected, the signatures on these two computers will look completely different. So taking a fingerprint using the on-access scanning, the first engine there, will not really be sufficient. I mean, we can't detect these types of malwares using signatures. Live protection will also be out of the question because it's changing shape for every infection. So even if we detect this in China, we can't protect your computer because it will look completely different once it's infecting your computer. So if you remember the steps that this Cryptolocker does is basically, first of all, it establishes a connection to its home botnet server, command and control server. So with our malicious traffic detection, if we see this communication being established, we can directly say that this is malware and tell our HIPS engine to disinfect this particular piece of file that's trying to contact or trying to collect an encryption key. We see really good detection rates if you're using the malicious traffic detection engine when it comes to these types of malwares. Also want to give you a heads up, because many vendors, other security vendors, they usually have similar features. Maybe they call it something different, but what they usually do is, by default, they have these security features turned off. If you would install Sophos on your endpoint, all of these different engines or these different filters will be automatically turned on. So I would advise you to just double check. So as I mentioned, behavior analysis is something that's really important that you actually run in your system, and just make sure that you actually have that enabled as well. When it comes to Sophos firewalls, we have a lot of different filters on the firewall as well. So IPS, intrusion prevention systems, web protection, advanced threat protection, email protection, and selective sandboxing. So these are just a few of the different filters available on the UTM. And once again, these different modules can also talk to each other. So for example, if we see something, an email passing through, we can say to the web protection, okay, we'll let this particular email through, it had a link in it, can you have a look out for when a user, if they click on this particular link, we see something suspicious with it. But what we're doing with the whole project Galileo is basically combining the strengths that we have in our endpoint and in our firewall. So instead of just having individual security systems, why not combining them so that they can actually also talk to each other? So here you can see a more holistic view of how our endpoint protection works. All the different, you have the live protection, malicious traffic detection, and so on, HIPS there as well. And on the UTM side, email security, web filtering, firewalling, and so on. So what we've introduced is something called a security heartbeat, so that the two separate systems can communicate to each other. So let's take one example here. We have a computer. It's trying to establish a connection to a botnet server, for example. The advanced threat protection on the UTM detects this communication. It can then automatically see, okay, this computer is compromised. The firewall can then automatically isolate this computer so it can't communicate to anyone else in the network. We can also tell the endpoint protection that we see that your computer is infected by something. Can you please have a closer look at the processes running on your endpoint and block and remove the malware that's running, and also ensure that no other computers in the network is infected by the same piece of malware. And all of this is done automatically without the admins having to do anything. So basically, if you're running the Sophos firewall in your system and the Sophos endpoint protection, you'll automatically have this feature. If you want to, of course, you can disable if you don't want to use it. But it will take care, and once the computer is disinfected by the malware, it will automatically tell the firewall again, I've removed the malware, I'm clean, I can access all the internet resources and so on. So we're working with 3 different stages of being infected. So we have a red light, yellow light, and a green light. Green light means that you can access anything. Your computer is up to date, your computer has no malware running on it, and so on. If you have a yellow light on your computer, it could be something like you're running a potentially unwanted application, or you have something suspicious on your computer. we can say, okay, you have a yellow light, you're still allowed to access internet, but you can't access internal servers in our network. And red light could be if your computer is infected by malware, you have an out-of-date, you don't have the protection updated, or the antivirus is turned off altogether. Then you get a red light, no access to nothing, you're completely isolated. So, do we have any questions so far?
Will you come to malicious traffic detection a little bit more in more detail a little bit later, or?
No. What do you think? The malicious traffic detection. What would you like to know?
Well, how you actually doing it, and what is background, and what is the success?
Okay. Yeah. So. Can tell you a little bit more about it. So basically, malicious traffic detection. What we have.
Well, let's put it this way also, that does it cover, for example, corporate environment DLP needs or not?
What do you mean?
This famous data leakage prevention.
No. So this is just to detect traffic to malicious sites. So what we have in the malicious traffic detection is basically a blacklist of sites that we currently know are botnets or command and control servers. So Sophos Labs has 5 labs across the world, so we collect all this malware, we run it in a sandboxing environment so we can extract the different botnet server that these pieces of malware are trying to communicate to. We take those addresses and basically put it in the malicious traffic detection.
CNC and drop site IPs.
Yeah, exactly. So it's very much a blacklist in that sense. However, it can also have behavior things like, for example, the key exchange. We've put that in as well. So if we see that someone is trying to exchange keys, we can block that behavior. Which also makes it very not heavy on the endpoints, so which is nice. So you don't have to, and I mean, that's one of the key reasons why many other vendors are actually turning off security features by default, like behavior analysis and so on, because it will bog down your computer and you don't want that. However, with Sophos, we have everything turned on by default because we see that that's very important for your security. So,
does any of these work with tablets, Android tablets, or? So
on the Android, we have our antivirus. So some of the modules are included on the Android. Currently, live protection, we have the threat engine and some behavior analysis, not as complex as the behavior analysis on the Windows machines. We're working on adding the malicious traffic detection as well, so from Q1 next year, something like that, we'll also add malicious traffic detection to the Android antivirus.
What about Mac OS?
Mac OS, it's already running on Mac OS. Okay, so just to summarize a little bit, we have very nice, one of these whiteboarding things. So basically, hackers, if you take the bad guys, they either focus on getting to your corporate documents or computing resources. Those are the 2 targets that has any value for the bad guys. And usually, for 20 years, we have protected our corporate data using antivirus solutions on the endpoints, and on the gateway level we've used firewalls. And throughout the years we've added different components like this key here, for example, encrypting our documents to ensuring that it doesn't fall into the wrong hands, mobile device management to also protect our mobile devices. On the gateway level we've added spam protection, web filtering, and being able to also provide wireless is something that has exploded throughout the last couple of years. So vendors like Sophos, for example, has created different bundles, like UTM here, for example, to combine all these different components into one product. However, over the last couple of years we've seen a lot of new types of malware that has been really effective in going through all of these different security filters, like snowshoe spams, heartbleed, shell shock, Cryptolocker, and so on. And what can happen is that sometimes it also managed to actually remove the antivirus protection on your computer. So therefore we have the Secure Heartbeat, basically combining these two products into one, so you can have a way to both manage your endpoint protection and your gateway protection. And Sophos can do this because we are 50% of our sales is on endpoint products and 50% is on our firewalls. Meaning that we put 50% of our R&D resources on the endpoint and 50% of our R&D resources on the UTMs. And we also want to give our users an easy way to manage this, so we do that for partners using the cloud, so partners can have a cloud dashboard, and for the end users, they can also have a cloud dashboard where they can manage both the firewalls and the endpoint protection from one single console instead of having separate consoles. So, that's what we call synchronized security. Well, that's it for me. Do we have any other questions? Yeah.
Since we already started talking about this, can you maybe tell us what is the spread of attacks in terms of operating systems? So you talk about Android and Mac OS and these kind of things.
Yeah.
And so maybe also what are the trends? So what is rising and what is kind of?
Yeah. So most, of course, of the malwares are on Windows. I mean, approximately 300,000 pieces of malware Sophos Labs detects every day for Windows computers. On Mac computers, it's approximately 30,000 pieces of malware every day. On Android devices, we see approximately 10,000 pieces of malware. However, I would say that Windows is probably today one of the more secure platforms, because Windows, if you have a Windows computer, you will also have an antivirus solution running on that system. You will have it protected with gateway protection and so on. If you look at Mac computers, I mean, everyone knows that if you have a Mac, you don't need an antivirus solution, right? That's not the case anymore. We've seen Cryptolocker and different variants of these types of crypto malware also designed for Mac computers. But today, actually the biggest hit rate on malware is on Android devices. So even though that stands for the smallest amount of malware coming out every day, only 10,000 samples, we still see that an Android device is usually not protected by gateway protection. It has direct connection to your operator, and it's not that likely that you actually have any antivirus solution running on your Android device. So the most common Android malware that we see is called Android rats, remote access Trojans. It can infect your Android device, and basically if you are infected by an Android rat, you can collect any data on that particular device, all attachment that has been sent to your email, your camera, your microphone and so on. These could easily be activated if you have an Android rat malware running on your Android device. One really tricky malware we saw on Androids, what it does is basically, it infects your Android device, and then it removes the password for your email. The user then opens their email client and get prompted with, please put in your password for your email. Most of the time they do that, so they just enter the password, and a keylogger will collect that password. They also have the domain that you belong to and the username you belong to, and basically what the bad guys then has is access to the corporate network, if you don't have that separated, but most customers don't. So, and as I mentioned, the hit rate on Android is much, much greater. So I would really recommend, if you have an Android device, you can download Sophos Mobile Security. It's free from Google Play. It's our antivirus app. So I don't see why you shouldn't do that. Yep. Yep.
Why are the features on Android more limited?
Why?
Yeah, what's the reason behind this?
Well, It's because
development resources.
could be no, but it's basically this is an emerging trend. So I mean, we've worked with antivirus for Windows for 30 years now. On Android devices, approximately 5 years. So development is a bit after there, but we're putting in a lot of resources, and also you don't have as much resources on a device as you do on a Windows computer. So we don't want to bog down the Android device too much as well. So that's one of the reasons. Any other questions? Okay, good. 3 minutes to spare.
Thank you.